Hi guys, so today we're going to write equations for parabolas. So we're going to review some things we've done so far, and then we're going to look at a couple new things to kind of combine this all together. So to start, just a review of what our three forms of a quadratic are. We've got standard form, vertex form, and the root form. But let's go ahead and look at this first one. So this is very similar to what we've been doing recently, where it gives you the vertex and the focus. So I'm going to go ahead and sketch this out. So this has a vertex of negative 1, 3, a focus of negative 1, 1. Well, we know our graph has to open towards the focus, so we know that this is a vertical parabola that's going to open down. So that means my equation will be y equals 1 over 4p x minus h squared plus k. We know that it's going to be a negative because it's opening down, and then the p-value, that distance between those two things, is 2. So this is going to be negative 1 over 8 x plus 1 squared plus 3. All right, look at the second one. This one really just gives us a lot of different vocab. So axis of symmetry, remember that's going to be the x-coordinate of the vertex. If the range is from negative infinity to negative 4 is the highest point on the graph, which is the vertex. And then the y-intercept we're going to use to help us solve for our a value. So my equation here, I'll start with vertex form. So I know h is going to be 2. I know k is going to be minus 4. So now I have to solve for a. So in order to solve for a, I'm going to use the information about the y-intercept. If the y-intercept is negative 12, that means that the point 0, negative 12 is on the graph. So negative 12 gets plugged in for y, 0 gets plugged in for x, and then I'm just going to solve from here. So that means that negative 8 is equal to 4a. So a is going to equal negative 2. So this equation would be negative 2 x minus 2 squared minus 4. All right, so continuing for this next one. So it tells us our vertex, and it gives us a point. It also tells us that it is vertical. That's important to know just because we could write a horizontal parabola that goes to the point 3, 6 and has a vertex of 4, negative 1. But in this case, we're writing the vertical equation. So that means I'm going to use a x minus h squared plus k. Well, I know h and k, so I know that this is going to be x minus 4 squared minus 1. I don't know a, though, so I'm going to use f of 3 equals 6 in order to be able to solve for a. So that means that 6 equals a 3 minus 4 squared minus 1. So a times 1 is equal to 7, so a is 7. So that means that my equation would be 7 x minus 4 squared minus 1. A lot of times in these problems, you were going to just solve for whatever that a value is. All right, so then we'll look at D. So I know my vertex, and then I know a root. So we'll start with the information I know. So x minus 6 squared minus 1. Well, if 4 is a root, then that means that 4, 0 is a point on that graph. So that means I can plug in 0 for y, plug in 4 for x, and I'm solving for a. So I get that 1 equals 4a, so a is going to equal 1/4. That means that my equation would be 1/4 x minus 6 squared minus 1. All right, so now we're going to look at writing these equations just based off words and transformations, and I'm going to edit these sum to match your notes. All right, so looking at this first one, so we have that quadratic that's already there. I'm going to start by shifting this left 3, then vertically compressing it by a factor of 2/3, and then after that I'm going to shift it up 1. So if I am shifting this graph left 3, then that means that I'm going to take that shift and I'm going to add 3 to that value, because if I'm going left 3, it's written as plus, so this would be x plus 3 as a transformation. So that's going to change this equation into x plus 2 squared. Vertical compression by a factor of 2/3 would be a 2/3 multiplied out in front. And then a vertical shift up 1 would be a plus 1 at the end. and this is our new g of x function. All right, horizontal compression by a factor of 3/4 in the next one. This is probably the biggest mistake, so just be careful. If it is compressed by a factor of 3/4, 3/4 is not the number that goes in our equation. The number that's going to go in our equation is going to be 4/3. And it's going to go inside the parentheses. Shifting down 3 would then be a -3 outside the parentheses. Then I'm reflecting this over the x-axis, which means I am taking the entire equation, and if I'm reflecting it over the x-axis, I am making this negative. So one important difference between these two questions is the order that these transformations were applied. So on this first one, I was compressing it, then I was shifting it up 1. Whereas on this next one, I'm compressing it, then I'm shifting it down. Horizontally compressing it, then I'm shifting it down. After it's shifted down, I'm reflecting over the x-axis. Since that reflection is happening after, it's going to affect the transformation that's already there, and it's going to instead make our equation negative 4/3 x squared, and now that becomes +3. So just pay attention to the order in which you're applying these transformations. All right, looking at our next one. This one is not a parent function, and it's not in vertex form. So it's really important to understand how to write these transformations in function notation to see how it's actually going to affect your graph. So if this graph were shifted to the right 3, what that would look like as a transformation, this would be f of x minus 3. If it was shifted up 2, that +2 would be outside of it. So what we're going to do is we're going to apply that to our f of x function. So that means our function is going to become x minus 3 squared minus 5, x minus 3, and then I'm going to add 2 to it. Well, then that gives me x squared minus 6x plus 9 minus 5x plus 15 plus 2. Combine our like terms together, and that gives me plus 26. So that is my graph after it's been shifted right 3 and up 2. Well, now, after I've done those transformations, I need to reflect over the y-axis. So reflecting over the y-axis as a transformation is f of negative x. So that means in that function, I'm replacing every x with a negative x. So that makes my equation x squared plus 11x plus 26, and that is my new g of x function. All right, so the next thing we're going to look at is a little bit heavier on the algebra, and this is a little bit of the newer part. So what we're going to do is basically, given some of these roots, we're going to determine what our equation is, and then we're going to write these in standard form. So on this first one, what we're going to do is we're going to write the equation of a parabola where the only root is 2, it opens down, and it has an a value of 1. So on this equation, what I'm going to do, I'm going to write this in root form. So we know our a value is 1. We also know it opens down, so really it's negative 1. One of my roots is at 2. Since that's the only root, we know that that's the vertex, which means in vertex form, that's going to be my h value. The k value here is 0, because if the only root is 2, then that means that that is the vertex. And that graph would look something like that. All right, so now let's look at the next one. The next one gives us one of the zeros, but that's not the only 0. The nice thing is we don't need to, it's easy to determine what the other 0 is. Our complex solutions and our irrational solutions are always going to come in pairs. So what that means is that if 2i is a root, negative 2i is also a root. So if I write this in root form, then I would have x minus 2i and x plus 2i. Then I can FOIL this out. So that would be x squared minus 2ix plus 2ix minus 4i squared. Minus 4i squared we know is really just plus 4. Those middle terms cancel out. And then I have x squared plus 4. So now from here I just need to solve for the a value, and I'm going to use the information that I have on there. So I'm going to replace x with negative 6. I'm going to replace y with 5. And then I'm just going to continue and solve here to get a. So that was squared. So 5 is equal to 40a. So a is equal to 1 over 8. which means that my equation then would be 1 over 8 x minus, sorry, we're not in vertex form, 1 over 8 x squared plus 4, and we're writing this in standard form, so then this is going to be 1 over 8 x squared plus 1/2. Now, one thing about quadratics that you'll notice, we're also going to talk about this a lot when we get to polynomials. All these quadratic equations are of a degree 2, and they're all going to have 2 roots. All right, so even though 2i was the only root that's listed, negative 2i also went with it. When we get to irrational numbers, 1 plus root 2 if that's an answer, 1 minus root 2 is also going to be an answer. In this case, on the first one, 2 was the only root, but if you notice, that factor was squared. So it really is a double root, and we're going to talk about that a lot when we get to multiplicities with polynomials. All right, so now we're going to look at one that has an irrational answer. All right, so again, irrational and imaginary both come in pairs. So if 2 minus root 3 is an answer, 2 plus root 3 is also an answer. So this one, I'm going to show you guys 2 different ways to do this. If I work this out in root form, I can still get my answer, but the algebra behind it's going to be a little bit messier than a different way. So let me go ahead and write this out in root form. So this is a x minus 2 minus root 3 and x minus 2 plus root 3. So first of all, if I just drop those parentheses, one thing you'll notice, this would be x minus 2 plus root 3, and this would be x minus 2 minus root 3. One thing you'll notice is that this is the same thing as if I just drop the parentheses on the original. It's just in a different order. So typically, I'm not going to write those parentheses there because I am still going to get the same result. Even though each one's referring to a different 0, it does still give us the same total answer. So now if I want to write this in standard form, what I need to do is I actually need to FOIL this out. So to actually multiply this whole thing out, we'll start by doing x times x minus 2x minus root 3x. Then we'll go to the middle one, minus 2x plus 4 plus 2 root 3. Then we'll go to the last one. So then I have root 3x minus 2 root 3 and then minus 3. So then from here, there's a lot that I can simplify. So minus root 3x and plus root 3x cancel out. 2 root 3 and 2 root 3 cancel out. Then I can simplify what's left over. I've got x squared minus 4x plus 1. So then the last thing I need to do is just solve for that a value. Well, if the y-intercept is 2, that means that 0, 2 is a point on this graph. So if I plug in 0 for x, then I'm going to get 2 for y. Well, 0 minus 0 plus 1 is just 1, so I get that a is equal to 2. So that means that this equation would be 2 x squared minus 4x plus 1. And then to write this in standard form, we're going to go ahead and multiply it out. So 2x squared minus 8x plus 2. Now, there is another way to get to this answer without going through all of that work. So another way that we can look at this, I'll go ahead and work this out over here on the side. So this is not the answer for D. This is just an alternate way to get this answer. If I know that 2 minus root 3 is a 0, okay, I'm going to work a little bit backwards here. That means that x equals 2 plus or minus root 3 are solutions to that polynomial. So then the way that I can get there to write that quadratic, let's go ahead and just rearrange this. So I'll do x minus 2 equals plus or minus root 3. Well, now I'm going to go ahead and square both sides. So I'm left with x squared minus 4x plus 4. And that plus or minus root 3 doesn't matter. If I square it, I'm going to end up with 3. Well, now if I get the whole thing on one side, I end up with the same thing that I end up with here. So you can use either method depending on whichever one you think is going to be easier in order to get to your solution. All right, let's go ahead and try D. We're going to do the same thing. You can also use this method on D. So if 1 minus 2i is a root, 1 plus 2i is a root. So that means that I can set this up in root form and do x minus 1 minus 2i and x minus 1 plus 2i. I can FOIL it all out and I can get my equation. Or I can do this the same way I just did the last one. I could say x equals 1 plus or minus 2i, and then work backwards to get my equation. So x minus 1 is plus or minus 2i. Square both sides. So that gives me x squared minus 2x plus 1. That gives me 4i squared. 4i squared, we know, is just going to be negative 4. So then when I add it to the other side, that's going to be x squared minus 2x plus 5. And then this one's a little bit nicer. It just tells us what the a value is. It just says it's 2. So then I can go ahead and distribute. So I get 2x squared minus 4x plus 10 is my equation. All right, we'll do a couple more that have a little bit of algebra to them. These next two are both going to involve systems. So we saw a question like this closer to the beginning of the year when we were starting our 3x3 systems. What we're going to do is we're going to base this off of standard form. So ax squared plus bx plus c. Well, in this standard form, of these 3 points, none of them are the vertex. I have 3 unknown variables, a, b, and c. Well, in order to write this equation, if there's 3 unknown variables, I need 3 equations. So each of these points is going to give me an equation. So I'm going to start with the first one, 0, 1. So 1 is going to be the y value when I plug in 0 for x. All right, the next equation I would have, if I plug in 10 for y, that's the result of plugging in 9 for x. And then my last equation, if 25 would be the y value when I've plugged in negative 6 for x. Then from here, I need to solve that system. Well, if you're given the y-intercept, you're going to have a pretty simple system to solve because 0a plus 0b, that means just c equals 1. If c equals 1, then I can just plug that in to both of those values. So then I have 10 equals 81a plus 9b plus 1, and 25 equals 36a minus 6b plus 1. So then to solve these, let's go ahead and just put them in another form. And one thing you'll notice now is that we can reduce both of these equations. So that top equation, everything's divisible by 9. So I'm going to rewrite that as 1 equals 9a plus b. Everything in the second equation is divisible by 6. So I'm going to rewrite that as 4 equals 6a minus b. Well, now this is a really easy equation to use substitution on. So 15a equals 5. So a is 1/3. Once I know what a is, I can take it and plug it back in. That means that 1 is equal to 9 times 1/3. That means that b is equal to negative 2. So now I know a, b, and c, so I can write my final equation, which would be 1/3 x squared minus 2x plus 1. And the next one on here, that is also a systems question. It's just going to be a 2-variable system instead. So this time we know the axis is symmetry. So I'm going to use vertex form. So since I know vertex form, I'm going to go ahead and plug in the axis of symmetry is my h value. But I don't know the k value, and I don't know the a value. What I do have, though, are 2 different xy coordinates that I could plug in order to have a system. So 2 variables is going to give me 2 equations. So 7 equals a, negative 8 plus 5 squared, and 20 equals a, 5 plus 5 squared plus k. So those equations I can rewrite. That's going to be 9a plus k. This is 100a plus k. And this one's going to be a little bit messier on our numbers, but let's go ahead and solve this system. Let's use elimination, so I'll multiply everything by -1. So -13 is equal to -91a. So a is equal to 1/7. Once I know what a is, I can plug that back in. So 7 is equal to 9/7 plus k, and it's not going to be a pretty answer, but I end up with k equals 40/7. Then I can plug both of those things back into my equation. So I get y equals 1/7 x plus 5 squared plus 40/7. All right, the last thing we're going to look at is just off of a graph. And then what's nice about these when they're off of a graph, it's really the same equations we've just done. You just need to determine what information you have and what information you're going to use. Some of these, it'll be very easy to determine what that a value is just from looking at the picture, just seeing what kind of stretches and reflections you have. If you're not able to do that, just pull some of the information that we've used, like the vertex and another point, and solve for a or something along those lines. This first one, this is a good case of using the directrix to find the p-value. So we know this one's opening to the left, so we know this is going to be x equals. We know it's going to be a negative value because it's opening left. So then here, my vertex is at 0, and the scale here is a little bit different. My vertex is at 0, 6, which means x equals 5 is my directrix. So the distance between those two things is 5. So it's going to be 1/4p. So that's going to be 1/20. Again, it's negative because it opens left. Then remember, it's y minus 6 squared. And then since my k value, or my h value here is 0, it'd be plus 0 there at the end. All right, look at the next one. On this one, I can at least see the vertex. So that vertex is at 2, -1. It's opening down, so it's going to have a negative a value. If I can't tell what that a value is from the graph, I can use another point. So I have the point -1, -4, and if I want, I can use that to solve for a. So let's go ahead and do that. So this would be x minus 2 squared minus 1. So let's go ahead and add that 1 over. So -3 is equal to 9a. So a is equal to a -1/3. All right, you also could potentially tell that from the graph, just knowing what you know about your parent function. What you know about your parent function, typically it went over 1 and down 1, which it obviously did not do, and it's been compressed. It's hard to tell exactly how much it's been compressed because we can't see what that point is. What we do know, though, is typically from the parent function, it goes over 3 and then down 9. Since it didn't go down 9, it just went down 3, that's another indicator that that's that change. So instead, that graph has gone by a distance of 1/3. So this equation would be f of x equals -1/3 x minus 2 squared minus 1. All right, and this last one, we can't really tell where the vertex is, but we can clearly see the roots. So here's a root and here's a root. The vertex will be halfway in between those roots, so we can at least tell the x-coordinate of that vertex pretty easily. It's going to have an x-coordinate there of of 1.5. But let's just find this one using root form since we've already done that. So with root form, we don't know a. We do know that my roots are 0 and 3. So if I want to solve for that a value, I can just pick another point in this graph, such as 3, -8. And I realize that's 2, not 3. So let me plug in 2 instead. So I get that -8 is equal to -2a. So a is equal to 4. So then from this graph, again, I would use my vertex. Or I guess we're using standard form on this one. Let's go ahead and just do our standard form. So a is 4. distribute it to the x times the x minus 3. So that would be 4x squared minus 12x. And that's that equation in standard form. So again, it just depends what information you have that's easy to tell and which form that you want to use. All right, so if you want extra practice working on these from the graphs, if you go to Schoology, there is a Desmos activity that allows you to kind of check your work and check your answers by picking some of these values and plugging them in.